Hello, Mr. Melo here, your online math teacher, and welcome to my channel. Today we're going to be continuing my series of videos on logarithms and exponential functions. And in particular, we're building on my last video. So in the last video, I introduced the three main laws of logarithms, which you can see posted here. But what I left off at the end of the video was the proofs for those laws. So we went through how to apply the laws, but not how they're proved. So this video is solely dedicated to proving these laws for you, because it's a good idea to have a rough idea of it. Now, the way we're going to begin is by using our knowledge of the exponential form versus logarithmic form. So we're going to prove this first law first. Now, I'm going to do a clever substitution to begin with. I'm going to take this big A to be equal to a to the little a to the x, and b to be equal to a to the y. Now, you might be asking, how can I do this? And it's because we said a and b were positive numbers. So when you think of a picture of an exponential function like these, the range of an exponential is all real number, or not all real numbers, all positive real numbers. So no matter what a and b were, there's going to be some value of x or y I could pick to raise a to be able to get those values. Now, one of the main reasons why we did this was because when I take this exponential form and write it as my logarithmic form, it looks exactly the two pieces I have on my right hand side of the equation. So, now here's where the magic comes in by defining them this way. If I start with the left-hand side of my equation, and I replace a and b with those clever substitutions I made up top, I know that because a to the x times a to the y are both exponentials with the same base, I can combine them by adding their exponents. So it becomes log base a of a to the x plus y. But we can now apply one of our nice simple properties for logarithms here, because it's a base a logarithm and an a to some power inside. So this is just x plus y. Now here's where my little note going back between exponential and logarithmic form comes in handy. X is equal to log base a of big A. So log base a of big A. Y, is equal to log base a of b. Log base a of b. And this is exactly my right-hand side that I wanted to prove. So we see that the left-hand side of our claimed law is equal to the right-hand side, so we've proved it. So this is our proof of one, that addition rule for our laws of logarithms. And we can do a similar trick for our second law, the subtraction law. So we're going to let big A be little a to some power and big B be little a to some power. And we can do this for the exact same reason as we did in proof 1. Then I have the following if I start on the left-hand side of my equation. I make my substitution. Big A is little a to the x. Big B is little a to the y. Because this is a fraction and little a is a common base, I can combine our exponents with subtraction inside my logarithm. So this is really log base a of little a to the x minus y power. And again, just like that trick we used up to in proof 1, log base a and a to some power are going to undo each other to just leave me with x minus y. This is one of the nice properties. And x, just like in proof 1, is the same thing as log base a of big A. So log base a of big A. Y is the same thing as log base a of big B. And this is my right-hand side, and I have proved the second law. So now we have our addition law and our subtraction law proved. all we have left is our exponent law. And our exponent law is actually, in reality, you can think of it in some cases a consequence of the first proof or our addition law. But we're going to start the same way that we started the last two proofs. So I'm going to let big A equal to little a to the x power, which we can do again, just like in the previous two proofs. And then I'm just going to see what I have. I'm going to start with my left-hand side. And when I substitute big A with little a to the x power, I now have that all raised to c power. And your rules of exponents say a power to a power is going to be multiplication here. So I can deal with this by multiplying x and c. So log base a of a to the x, I'm going to bring it out front, cx. Again, just like in the previous two problems, log base a and then a to a power undo each other in a sense. So this just leaves me with c times x. But for the same reason as the two things above, when I take my big A is equal to little a to the x and write that in logarithmic form, that gives me back log base A of big A, leaving me with the right-hand side of my equation, proving the third law. So here's the proofs of these three laws of logarithms. What they really involve is some clever substitutions and then some applications of our properties of logarithms, and just letting kind of the substitutions unravel themselves in a nice way. So I hope you found this video helpful. I normally don't make students have this memorized, but I think it's good for you to see. If you liked the video, like I said, hit the like button and have an awesome day.